are some questions that floating around about the bubble and comparing it to the year 2000. A software engineer, right? Mm-hmm. AI coding. Mm-hmm. It's going to be a couple of $1 trillion market. Okay, so how do you scale this out? How do you deliver this intelligence to all of these different applications? Well, that's what we build today. There are several reasons why infrastructure is being built so fast, and there are some questions that floating around about the bubble and comparing it to the year 2000. And so just to compare it, during the time of 2000, internet companies, there were hospital.com, there was pets.com. Most of the internet companies were not profitable, and the size of the whole internet industry was about $20-30 billion, if you recall. Mm-hmm. And today, the first thing you need to observe is that AI isn't just about the brand new companies, OpenAI and Anthropic and others. AI is transforming the way that hyperscalers do work. Like, for example, search is now powered by AI. Recommender systems, how you see ads and news and stories are now movies generated by by AI. User-generated content. So basically, Google's business, Amazon's business, Meta's business, hundreds of billions of dollars of revenues are all powered by AI now. Even in the absence of OpenAI and Anthropic, this entire hyperscale industry is being powered by AI. And so the first thing to observe is that whole thing needs to go from classical CPUs with classical machine learning to now deep learning with AI. Mm-hmm. So that transition alone is hundreds of billions of dollars. Does that make sense?
Absolutely.
And so that's one. The second thing is that we now have this new market. This new market is called, AI, and it's got a new industry, and they produce AI. Mm-hmm. And so OpenAI's, the Anthropics, the xAI's, the Gemini from Google, of course, and Meta is going to be an AI maker. And so this entire layer of AI model makers is also building AI factories. And these AIs are going to power the next generation of new opportunities. And this is where the Harveys, the open evidence, the cursors, I mean, you see all of these AI native companies, and they're going to be connected to AI models, and they're going to go after, for the very first time in history, an industry that never was addressable, and that's the labor industry. Mm. And it's digital labor, called agentic AI is going to supplement and augment the enterprise market. So for example, Nvidia already today, we use 100% of our software engineers, 100% of our chip designers. Every single engineer today is augmented by Cursor. We use Cursor largely inside our company. And so we now have AIs for all of our engineers. Productivity gains, the work that we do so much better. You also see that there's a new industry showing up. It's called physical AI. So you have enterprise AI, you have physical AI, are augmenting labor. And so, for example, a robo-taxi is essentially a digital chauffeur, mm-hmm. right? And we're now going to have AIs that are going to be embodying, going to embed into anything that moves. And so in the case of robo-taxi, it's a steering wheel and wheels, but you're going to pick and place arms. You're going to have one arm, two arms. You got 3 legs, all kinds of different embodiments. And so these two industries represent about $100 trillion of the world's economy. And for the very first time, we have technology that's going to be able to augment that. And so that's the reason why people are so excited about the next wave of AI.
So let's talk for a moment on the previous wave, because you mentioned how AI has already been offering an ROI. And for the investor audience, I think the Meta example is a great case study, because in Q4 2022, Apple basically removed attribution data from Meta. And you all saw hundreds of billions of dollars of market cap decline. And the Meta team said, how are we going to fix this? They fixed that with AI powered by Nvidia GPUs.
That's right, yeah.
And they got their attribution back up to where it was, and that has recovered many hundreds of billions. It's over $1 trillion higher than it was at its low. And that is all ROI that was powered really by your GPUs.
What Meta was classically, not just Meta, but is one of the most complicated systems, software systems, is called a recommender system. And there's a couple of basic technologies. One of them is called collaborative filtering, which is based on what I'm doing and looking at what everybody else is doing. If we have similar patterns, it would recommend maybe the same movie to me, the same next item in your grocery list, a book to me, a video to me, so on and so forth. And then the other thing is called a content filtering, just based on who I am and my preferences, and based on what that book actually is, you might be able to recommend that book to me. And so that recommender system is the largest software ecosystem in the world. And that ecosystem is moving very significantly, very quickly to AI. And so you're going to need a mountain of GPUs.
And those systems were made famous by the Netflix challenge a couple decades ago. Now Netflix, their recommendations are all powered by AI, and Amazon, as you said, when you go and purchase something, a significant number is by a recommendation system.
Moving
AI.
search to AI.
Moving search to AI, all of this is being powered now.
TikTok to AI. Right?
Yeah, all of
Google
TikTok.
Shorts, AI. I mean, without it, and now all of the personalized ads are going to AI. Yeah, so just amount of AI is just incredible. And that has nothing to do, notice I've just described a whole bunch of classical use cases. Well, quantitative trading is going to move to AI. What used to be human engineered feature extraction is going to move towards AI.
And I think that's actually an area that Citadel Securities has pioneered for the past 20-some years. So that's the classical AI.
Citadel's a great customer. Thank you.
So that is a classical example. And for the investor audience, talking about AI ROI, it's already there in the form of trillions of market cap. Let's talk about what's next for spend. So 2025 estimates can be as high as $500 billion of AI investment in the ground. Where do we go from here? Does this become a multi-trillion-dollar a year investment category?
Yeah, so the manufacturing, the foundry part of AI, if you will, is the model makers. They're kind of like, think of them like wafer makers. The applications of that, and one way of thinking about AI is the large language models. That's the operating system, if you will, of the modern computer. And you build applications on top of these AI models. Not just one AI model, but a system of AI models. Okay, and so applications have it's going to have a collection of different AIs that it connects together. And so the question is, what's the application space on top? The most sensible way of thinking about the application space on top, aside from all of the whatever applications we have are going to be improved by AI that we've been talking about, a simple metaphor is just digital humans. And so a digital software engineer, right? AI coding. It's going to be a couple of $1 trillion market opportunity probably. AI digital nurses, AI accountants, AI lawyers, AI, right? So there's AI marketeers. So that we call all of that agentic AI. And that technology is evolving very nicely. And so for the very first time, technology is no longer just a tool used by accountants, tools used by software engineers. We're going to become digital software engineers. And I wouldn't be surprised if you license some and you hire some. And so depending on the quality and depending on the deep expertise. And so future workforces in enterprise will be a combination of humans and digital humans, and some of them will be OpenAI based, and some of it would be Harvey based, or Open Evidence, or Cursor, or Replit, or Lovable, or some of it will be third party, and some of them you'll home grow. And so we home grow a lot of our own AIs because we have a lot of proprietary knowledge and data that we want to protect, and we have skills in developing those AIs. Over time, more and more people will be able to cultivate their own digital AIs because it'll just be easier to do so. And so enterprise agentic AI, obviously augmenting the labor force is trillions of dollars of opportunity. And what's unique about AI also, versus previous software is that AI needs to think. Meaning you can't pre-compile it, put it into a binary, download it, and use it. It's got to process all the time. And the reason why it has to process is it has to take your context, it has to think about what you want it to do, and then produce an output. And so it's thinking and generating. It needs a machine. It needs computers to do that. And that's the reason why AI factories exist. And so these AI factories will be in the cloud. They might be on-prem. They'll be all over the world. And it's part of the AI infrastructure, if you will. But there's going to be a whole lot of thinking to produce these we call them tokens, but basically intelligence. And so that's the cognitive AI, the digital workforce, if you will. And then the second one is robotics. For the very first time. So let me give you a thought experiment. Why robotics is so close. As you know, you can now prompt an AI, and it could generate, prompt Jensen picking up a bottle, opening it, and taking a sip. Okay, and it would generate the video of me, right, opening up a bottle, taking a sip. Well, if it can generate all that, why can't it maneuver a robot to do that? And so, your thought experiment would suggest that, that's probably very likely. Now, if you could design a digital chauffeur that could drive a car, why can't you have a physical robot drive a car? And so if you can embody a physical robot to even drive a car, why can't you embody a pick and place arm or any type of robotics? And so notice we have the ability to embody almost anything. We could pick up knives and forks, and it becomes an extension of our body, and somehow we articulate it. We could pick up a baseball bat and use it as an extension of our body. And so we embody these physical extensions. Future AIs will be able to embody, and manipulate a car, robotic arms, a human or robot, a surgical robot, so on and so forth. And so I think these two markets are within reach of AI. And then lastly, if I just give you one example, whenever you see the observation of one thing, the rest of it is just engineering, right? And so we've now seen the evidence of one excellent thing, which is an AI software coder, which is the reason why we use it so much. If you can have an AI software coder, why can't you have that AI software coder also write software to be a marketing campaign, or write software to help you solve any accounting, whatever you want to do. And so almost the existence of that says the rest of it is engineering. And then we now have robo-taxis. It's an embodied robot that controls a steering wheel and wheels. And if that exists, why can't you generalize that? And so the rest of it is just engineering. And so I think that's a good way to reason from first principles how likely it is we're going to be able to have this technology proliferate across industries and society. And then the next thing that you have to reason about is, okay, so how do you scale this out? How do you deliver this intelligence to all of these different applications? Well, you need AI factories. And so
let's talk a little more about robotics. You have an exceptional robotics team, one of your executives who runs robotics here today.
Yep.
In a previous conversation, you shared some insight about how robotics might play out. Is it going to be a single humanoid project? Is it going to be open source projects? How are those open source projects going to tie back? How do you think robotics will actually manifest in the physical world, and on what timeline?
Well, robotaxis are here now.
Yep.
And their ability to generalize from city to city to city is really, really getting fast. And the reason for that is because the same fundamental technology, we went through the same journey, and for all the quantitative trading, the algorithmic trading people in the room, you went from human engineered features, machine learning, to using more and more deep learning and embedding certain modalities and multimodality models to now largely end-to-end. And the reason why, and it's multimodal. In this journey, we became more and more generalizable. And the AI model that you use for self-driving car and the AI model that you use for a human or robot is highly similar. It's just in two different embodiments. And the reason why I know that for sure is because I can drive a car. And I can manipulate my body. It's the same intelligence. And so, and I could pick up fork and knife and somehow, pretend like I'm a surgeon, doing surgery on a steak, And so you could notice it's the same AI in different embodiments. And so that's where AI is going. Robotics is going towards a more and more generalizable AIs that are multi-embodiment. It's multimodality, it's multi-embodiment. And in order to create this future, you need three things. You need the AI factory I was talking about, where you have to train the models. And you need a place where the AI can learn how to be an AI without having to come into the world right away. So it could try trillions of different iterations inside a virtual world. Well, that virtual world resembles a video game. And so the AI is basically playing a game inside a virtual world like a video game character, and it obeys the laws of physics. And when it's done learning how to be a great video game player, because the sim to real gap is extremely low, because the simulator is really, really good. We call it Omniverse. That Omniverse computer, then the robot can come out of that virtual world, and this world become one more version of the virtual worlds it's played in. And it comes into the physical world. When it comes into the physical world, it needs a computer as well. So you need three computers. You need the AI computer, training computer. You need the simulation, the virtual world computer. And then you need a computer where the robot actually operates the brain. And so Nvidia offers all three of those computers. And we work with just about every robotics company, self-driving car company, robotics of different embodiments. And this is likely going to be one of the largest markets of all.
So Nvidia touches just about everything in technology now. And as you've said in the past, you start with $0 billion markets and have helped turn them into trillion-dollar markets. Robotics is one of the next frontier markets. Are there any other next frontier markets that you're particularly excited about? You mentioned healthcare a moment ago. Is that one you're passionate about? Are there others that the investors in the room should be on the lookout for?
Well, the technology needed for healthcare is really complicated, and we're making fast progress. If you can understand the meaning of words, sequences of characters, and you could understand the meaning of structures like the virtual world. Okay, like when you look at the reason why we're able to generate video is because we understand the virtual world to generate an image, a representation of the world. And so if you can generate video, it must be because you understand the world. If you can understand worlds, is it possible that you understand proteins and chemicals that have structure? And the answer is yes. And so we're increasingly getting closer to understand the meaning of proteins, AlphaFold and others. We're able to understand the meaning of cells, and we recently did a partnership with ARC, and Evo2 is one of the first examples of a large language model, a foundation model for cell representation. So you can now talk to it and say, I want you to generate other cells of these properties, or you could talk to a cell. What are your properties, and what can you bind to, and what can you your metabolism, what can you activate with? And so you could talk to a cell like you could talk to a chatbot. And so understanding the meaning of proteins, so anyways, there's a lot of progress there. I mean, the list goes on. I mean, I'm excited about the work that we're doing to bring AI into telecommunications. 5G and 6G will be revolutionized by AI. I'm excited about the collaboration we have with quantum computers, so that we can pull in the quantum computer schedule by about a decade by creating quantum GPU hybrid computing systems, where we do the error correction, we control the quantum computer, we do the post-processing. And so we have a new architecture called CUDA-Q, which extends CUDA to quantum. And that's getting incredible adoption. And so there's a whole bunch of problems we can now solve that were hard to solve before.